Коллеги, добрый день. Подскажите,
Good evening, ladies and gentlemen. Please raise your hand if you experience the following. Something alerts in the SIEM, but the ERP system does not show anything. Have you ever experienced anything like it? Well, some of you might, some of you may not have. Well, my name is Kirill Rupasov. I've been in IT for over 17 years. I've been specializing in InfoSec for over 13 years, and I've been focusing on SOCs for over 5 years. So, like I said, sometimes you come across the following situations. They might not be frequent, but they happen anyway. An event is detected by a SIEM system, but for some reason it doesn't go to an ERP system. How come? Maybe the network has been rebooted, maybe the service goes into a service mode, or for some other reason this might happen, and that's it. I experienced two examples like that when it had a direct impact on our organization. First, the network kernel crashed, and a network session failed, and the customer noticed that because he ran a pen test at the very same time. The second time I experienced that was during the standoff. We were flooded with incidents. So there were 150 incidents per minute. 150 incidents per second, and our services crashed. Why does it happen? First and foremost, it happens because when SIEM sends data on an event to ERP, it uses a trigger. In other words, a trigger goes through the webhook, and the SIEM does not check whether it is delivered, whether the event was delivered, whether it went to the right field, or maybe the system was in the service mode. And the SIEM is not going to repeat the alert for the second time, which means that you're going to lose it. If you launch a scheduler in the ERP system, your events will be re-requested, but if it's a regular error, then you get a cumulative error ultimately, and this error replaces the normal events, and you cannot get data on them. The same happens if you get information on too many events. And at the end of the day, you will only see just one page, or it's going to be a denial of service, which is not good. So how do we counter that? Shown on the screen is a flow chart showing the way we try to counteract. We have a script producer that gets data on the events. So there is a consumer that distributes the events by enriching the ERP, and there is a sequence broker that regulates the flow of events so that we do not get overflooded, but on the one hand, but on the other hand, it guarantees the delivery of all the incidents. Well, the script producer runs in the following way. It gets data on an event in small packets. Thus, it prevents the so-called overload. You are not going to see any out-of-memory incidents. And at the same time, it confirms a delivery. In other words, as soon as the event goes into the queue broker, the event is confirmed in the SIEM. And the confirmation is only given when you guarantee that the event makes it into the broker, not earlier. And that guarantees the delivery. As for the script consumer runs in a very similar way. Both the queue broker, we get an event from the broker and send it to the ERP system. And only after we move the event to the ERP, do we delete the event from the broker. If there is an error at this stage, the event goes to the end of the queue. So what are the risks?
Уход в цикл при
Looping.
обратно в конец очереди.
If the event goes back to the end of the queue, that's one of the risks. However, since we roll out a meter of such moves, we prevent the loop, we prevent cumulative error, and we mitigate this risk. The pipeline turns out to be complicated. It's difficult to manage. This is true, but we can avoid this problem by logging every stage. Sometimes it works even better than SIEM because we guarantee the move of the event and it is recorded in a log. As for redundancy, the script works well. 8 cores, 16 RAM of the memory is not much compared to SIEM, so there are no risks in this regard. Let's talk about the plugin. I demonstrated in the flowchart, and we run the plugin when all the events are transferred from the broker to ERP. The business the data analyst has info to work with. In any case, the incident will be delivered to the analyst, and we can guarantee no problems if something freezes or starts experiencing technical problems. Incidents will be recorded for the analyst in the system. And when the scripts are run, we can block incidents in such a way so that the analyst does not affect the data fed into the ERP system. I gave you details in my previous presentation on why that is needed. Scan this QR code to go to my previous presentation. It's quite interesting. For every script, we have a mandatory time control. If the script takes longer than needed to run, then it crashes, the data is unblocked, and the analyst works without the script. Now, let me describe the script, the code itself, a bit. We use the import lib library. This library allows us to form a dynamic run of Python modules, and the reason for that is as follows. Every analyst develops his own modules. They understand the logic. They know what kind of data they need on an event, but not to dwell on how to work with the tool. They have a plug-and run manager that provides access to every single element in a system. And that means that a developer does not have to be concerned about authorizing in the SIEM to work with an element. And that's SIEM, logs, ERP. This is the way we feed data into the main plugin to start the function. We use the C plugin, the meta class plugin, and it is used to organize the access. And what's even more important, we use a decorator that ensures the login of the plugin. we can understand what is operational, what's not operational, and what crashed. And the decorator is used to run the main function. And last but not least, this is the module that we developed. It's a simple class module that restarts the word function. The plugin logic is executed here, and as I mentioned, our developer does not have to take an additional effort like login, log on, logging data, gaining access. Everything is done at a higher level, and he doesn't have to be concerned about that. So ultimately, what we have is as follows. We guarantee the delivery of incidents from the SIEM, and we will never lose them. Secondly, we can guarantee the delivery of events to the ERP system. And regardless of the mode it operates in, whether it's in the service mode or in a crash mode or the network crash, the ERP will still see a delivery of the incidents as soon as everything is up. We can also run scripts. You run a script, you enhance data, you get the results, everything is fine. Next bullet. We have a stage-by-stage control in the pipeline, and we are prepared to say that something is working, something is not working, and since we use an outside control system, we are not concerned about SIEM performance, and even if SIEM fails or some of its modules fail, we're not concerned. And even if it fails, we won't be able to deliver any incidents in the first place. The consumer script allows us to control event duplication or and ultimately that reduces the workload on our analysts. That brings me to the end of my presentation. Thank you so much for your attention. I'll be here for the rest of the day. If you have any questions, I'll be happy to take them. Thank you.